Hello Trig class. If you remember in that last video we were working out the inverse tangent of the tangent of 7 pi over 6. We had just worked out the tangent of 7 pi over 6. Tangent was opposite over adjacent in that diagram. And the diagram and the adjacent was minus the square root of 3. So I should not have put a 2 in there. I should have put in minus the square root of 3. So we get 1 over the square root of 3. All right, so now that we know that, we can figure out y, which is the inverse tangent of tangent of 7 pi over 6. So that's the inverse tangent of 1 over the square root of 3. But the inverse tangent of anything means that the tangent of the angle is equal to the value. So y is equal to the inverse tangent of 1 over the square root of 3 if and only if the tangent of y is equal to 1 over the square root of 3. And the y, by definition, has to come from quadrant 1 or quadrant 4. As we already talked about. So tangent is positive in the first quadrant. This is a positive number, so it has to be in the first quadrant. So we're looking for a triangle whose opposite side is 1, whose adjacent side is square root of 3. So opposite side is 1, adjacent side is square root of 3, which means this is a 2 because makes a 30, 60, 90. So the angle in here is 30 degrees, which is the same as pi over 6. So the answer to the question is the y, which is the inverse tangent of 1 over the square root of 3, is pi over 6. All right, next example, let's keep going. So we have this composition again. And the way we do compositions is we evaluate the inside, then move to the outside. So here's where the inverse sine function is in this one. Inverse trig function is, it's the inside function. So I go to my definition of my inverse trig functions, and I use the fact that y is the inverse sine of minus 4 over 5 if and only if the sine of y is equal to minus 4 over 5. And the y's can only come from quadrant 1 or quadrant 4. All trig functions are positive in the first quadrant, so it has to be the fourth quadrant. And sine is opposite divided by hypotenuse. So I want to draw the situation where I'm in the fourth quadrant And those are the parts of my triangle. So there I'm in the fourth quadrant now. This guy is -4, because that would be opposite. And this guy is 5, because that's the hypotenuse. And then I don't know the adjacent side, but I can figure it out using Pythagorean's theorem. So we're going to call that A for adjacent and say that a squared plus 4 squared is 5 squared. So a squared is 16. I'll have to move it to the other side. It'll be a -16 plus 25. So a squared is 9. So a is 3. Okay. So I now want to take the tangent of y, and y is opposite divided by adjacent. Here's my y. That's the angle there. And in the picture, the opposite side is -4, and the adjacent side we just worked out was 3. Okay, so there's a little bit more practice. All right, and now let's go on to this one. Another composition. This time the inverse trig function is on the inside function. So just use your definition working on the inside function first. I'm going to change the notation from arctangent to inverse tangent, but they mean the same thing. So I'll work this out, but I'm going to go work on the inside first. So I go to my inverse tangent definition and use the fact that y is the inverse tangent of x if and only if the tangent of y is equal to x, and y comes from quadrant 1 or quadrant 4. So y is the inverse tangent of 0.4 if and only if tangent of y is equal to 0.4 and y comes from quadrant 1 or quadrant 4, but all of the trig functions are positive in the first quadrant, and this one is a positive number, so it has to be in the first quadrant. I'll think of 0.4 as 0.4 over 1, so that I have a opposite side and an adjacent side. So here she is, angle y, opposite side is 0.4, adjacent side is 1. And then I can use Pythagorean's theorem. I'll call it C for the hypotenuse. And the fact that 1 squared plus 0.4 squared is C squared. So if you add that together, you get 1.16. So C is the square root of 1.16. All right, so now I know this hypotenuse, and I can say that I'm doing the cosine of y, because I named y the inside part. Cosine is adjacent divided by hypotenuse. All right, so we go to our picture and we say the adjacent side is 1, and the hypotenuse is the square root of 1.16. All right. All right, the next one is a application problem, but because the only topic is inverse trig functions, which help relate angles to sides of a triangle. Pretty much all the applications are going to be relating a side of a triangle or the hypotenuse to an angle. So let's take a look at this one. In the description, they give you this picture, by the way. It says that there's a lighthouse. It's 0.5 miles away from this point, and we're given this side. And we need to get this angle in terms of that side, but that's what trig functions are for. Trig functions are for relating angles to sides. So we'll just use a trig function that relates this angle to these two sides. We want to use this side because it's a number we know, and then we want to use this side because it's what we're supposed to find. Tangent is opposite divided by adjacent. So the tangent of theta is opposite divided by adjacent. And then I'm supposed to get theta, the angle by itself, but that's what inverse tangent does. You just take the inverse tangent on both sides. So, also dividing by 0.5 is the same thing as multiplying by 2, so you could write this as 2x. We already did problems like this before, except we didn't keep going until we got the angle. We just wrote our answer this way, but now that we have inverse trig functions, we'll just do the one extra step, and that's taking the inverse trig function to get to the angle itself. All right, let's go on to the last one here, and it's composition again. So we're going to use the definition that's for the start for cosine inverse, which is y is the inverse cosine of x if and only if the cosine of y is equal to x and your angle comes from quadrant 1 or quadrant 2. So we're going to let y be that inside part, and then we'll use our definition that we just talked about to say y is the inverse cosine of 2x if and only if the cosine of y is equal to 2x and your y can only come from quadrant 1 or quadrant 4. Okay, and then to set things up, we'll think of 2x as 2x divided by 1 so that you have a adjacent side and a hypotenuse. So in a triangle, if 2x is the adjacent side, hypotenuse is 1, and we'll call this the h, height, for the opposite side. And we'll use Pythagorean's theorem to say that this side squared plus the height squared is the hypotenuse squared. So 4x squared plus h squared is 1. So if you solve for h squared is 1 minus 4x squared. So h is the square root of 1 minus 4x squared. All right, so in this expression, we just let y be that part. So we're looking for the sine of y, and y is opposite divided by hypotenuse. We just found the opposite side. It was the square root of 1 minus 4x squared. Hypotenuse was 1. So that's what you get. All right, that's it for this section.